Hello, welcome back to another video. Today I'm going to introduce you to my rough notebook from ninth grade. It's called oops. It's called Schrodinger's notebook. Yep, this is the inspiration for my channel. This is the inspiration for the name of my channel, not for my channel. Okay, so this has been I use this notebook only in ninth grade and haven't used it at all or even spoken about it since then. And recently, like yesterday before, I read through it to see what I written in it. And on one of the pages, I came across a really good formula which I derived for calculating the area of a triangle if you know all its sides, and another one if you know two angles and an included side. So I want to share them with you. So let's get to the first proof, which is basically SSS. Okay, so now you have, and as you see, the new background, new color, pretty cool. So we have this side, and this side marked. Oops. And this side marked C, and we need to find the area, which is basically delta. Okay, so now the one thing which I use for this is the cosine rule, where I found this angle, and using this angle I found this height and found the area. Okay, so let's see how we did that. So according to law of cosines, c square is equal to a square plus b square minus 2ab cos theta, which gives cos theta is equal to a square plus b square minus c square by 2ab. Alright, so now we have sine theta is equal to root 1 minus cos square theta, and we also have that delta is equal to 1 by 2 AB sine theta. Now why, you might ask? Because h is equal to a into sine theta, and half into base into height is the area. So we basically get 1 by 2 AB root 1 minus, I don't like angles or inverse angles, so I'll directly put this value over here. So a square plus b square minus c square by 2ab whole square. So eventually if you simplify it, it will come out to, wait, no, this is not right, yeah, 2ab square. So if you simplify it, will come out to root 4a square b square minus a square plus b square minus c square whole square by 4, and this is the area. Now one thing which I really like about this formula is that everything is in squares. So if you have weird sides like root 2, root 3 and root 4, then using the Heron's formula, it will be pretty tricky to solve it, because you'll have sum of roots and you have to multiply them with other sums, which will get really messed up, and you'll have to take a square root of them afterwards. Now over here, now I'll just show you how to do it with this. We'll take this as a, b and c. Now if we do with this, it'll just become squares of whole numbers. So 4 into a square into b square, 4 into 6, that's going to give 24, minus a square plus b square minus c square whole square, that's minus 1. 2 plus 3 minus 4, that's 1 divided by 4. So this answer is directly root 23 by 4. Alright. Alright, now for ASA. So we have any two angles and any side. It doesn't matter, because if you have these two angles, you can find the third angle. So you basically know all three angles, and if you know all three angles, it doesn't matter which side it is, as long as you know the two angles surrounding it. Okay, so now let's say that we know this side, and the two surrounding angles are theta and alpha. Yeah. Okay, so now we basically need to convert everything into this form, 1 by 2 base into height. So we know the base, and all we need to find out is this height over here. Okay, so how do we do that? Well, let's see. So we have this as a minus x, this as x, this side length, and we have h is equal to a minus x tan theta, and h is equal to x tan alpha. That we know because of basic tan properties. So now we have a minus x tan theta is equal to x tan alpha, which after solving we will get that x is equal to a tan theta by tan theta plus tan alpha, and we know h is equal to a tan h is equal to x tan alpha, and we know the value of x, so we can just put it in later. And delta is equal to 1 by 2 a h. A is the base over here, so 1 by 2 a x a square basically tan theta by tan theta plus tan alpha, and this is basically the answer. A for tan theta tan alpha. Yeah, so now if you see, like, theta and alpha are replaceable, so that shows that this formula has validity. Now there's nothing like super special about it like the other one, but this formula is pretty good because I don't recall any formulas about the ASA property. Like for SSS you have the Heron's formula, for the SAS we have 1 by 2 AB sine theta, which I used in the SSS property. But this formula I didn't recall any particular formula. If you know any, please share it in the comments, and please like, share and comment on my video, and subscribe to my channel for more such content. Thank you.